So, during the last classes, we were discussing about the different types of operators in use, operators used in C. Now, during that class itself, we said that there is some precedence of operators. That is, some operator has a higher precedence in the sense they have to be executed first before some others are to be executed. In school days itself, you might have studied a certain rule of the arithmetic, the precedence of the arithmetic operators like addition, subtraction, multiplication, and division. And in that case, you might have studied about this rule, that is the Bodmer's rule. Bracket of then division, multiplication, addition, and subtraction. So that is the rule that is guiding the operator precedence in the case of arithmetic operators. So in the case of C, we have different types of, we have different classifications of operators, and it is not the arithmetic operators that is present in C. So what we have to do is we have to follow the operator precedence while calculating, while doing these things. Unless we doesn't follow the precedence rules, what will happen in our C programs? We may be getting wrong answers in the sense if we doesn't put both the brackets wherever it is required, and if we doesn't put those brackets, that means our answers may be wrong. So that is possible. So we have to follow the rules put forward by the precedence of the operators. So let's see what is the precedence. The precedence of operators determines which operator is executed first if there is more than one operator in an expression. So if we have more than one operators in an expression, like A plus B into C, this is an expression. In this case, the same expression can be written in another way, A plus B. Using the brackets, we are writing this one, or A plus B into C. So in these two cases, even though the operators are the same, plus and multiplication, the addition as well as multiplication, and the operands are the same, A, B, and C, the result will be different. Different in the sense, in the first relation, what will happen is first this will be executed, that is B into C will be executed. Then the value of A is added to it. Suppose A equal to 1, B equal to 2, and C equal to 3. In this case, what will happen is, if we are considering this one, this expression, A plus B into C, first B into C will be executed. So B into C is 3, 3 into 2, that is 6. Then A is added to it. So 1 plus 6, that will be evaluated as 7. But on the other case, if we consider this relation, I mean this expression, in that case A plus B is within the bracket. So as per the Bodmer's rule, the bracket has a higher precedence than the multiplication. So the bracket comes first. So whatever is inside the bracket is executed first. So A plus B. So A is 1 and B is 2. So this is executed as 3. Then multiplied by C is again 3. So 3 into 3. So this will be evaluated as 9. So even if the operands are the same, the operators inside the things inside this one is the same. The expressions, the two expressions differs in the in values just because of the presence of a bracket. So you have to put sufficient brackets, or you have to consider the precedence of the operators while writing expressions inside the C program. Then the precedence of the operator determines which operator is to be executed first if there is more than one operator. So if there are more than one operator, then which is to be executed first, that is determined by the operator precedence. Then there is another term there, associativity. So the associativity indicates in what order the operators of equal precedence in an expression are applied. So if there are multiple operators with the same precedence like in the case of multiplication as well as division, multiplication as well as division have the same precedence. Plus and minus, the addition as well as subtraction, they have the same precedence values. So in that case, which is to be executed first, that is determined by the associativity. So normally the associativity tells in terms of the order in which these these operators appear in an expression, like from left to right. That is the operator which is coming to the leftmost side of the expression will be executed first. That is the left to right means left to right. Sorry. So that is the associativity. Most of the operators are having a left to right associativity. Only a very few operators are having a right to left associativity. Only two types of associativities are there. So one is left to right and the other one is right to left. So let us see which are the different operators and how the operator precedence comes. So the one that is given at the top is having a high precedence over the one that, and the one which is given at the bottom, they will be having a having the lowest priority. I mean lowest precedence. So in the case of this type of operators, that is the logical negation, bitwise one's complement, then unary plus, unary minus, the increment operator, decrement operator, the address operator, that is dereference operator, then the pointer reference, size of operator, then the typecast, that is how one type of data is converted into another type, that is the typecasting, that is the integer data used to be converted into double. So in that case, that is known as the typecasting. That we will study in this class itself, what is typecasting. So this is the order in which the operator precedence comes, and the associativity in all these cases is right to left. And this is only a single set of operators, and majority of the arithmetic operators, most of the arithmetic operators comes here. See, these are the arithmetic operators. So in the case of arithmetic operators, the multiply has a high precedence and the divide has a high precedence percentage. The remainder is also having a high precedence. And all these things, all these three items are having the same precedence. See, in the previous case, all these things are having the same precedence because within the same row, it means it is the same precedence. So all these members or all these operators are having the same precedence. So whenever these operators are coming in succession, it is taken, the associativity is taken right to left. So the which one is coming to the right, that one is executed first, then the left one is taken. So this is, in this case, it is right to left, not left to right. So in this case, the multiplication, divide, percentage, that is the remainder, etc. They are these three are having the same precedence, and the associativity in that case is left to right. So if A star B divided by C is coming, so what we have to do first is, or what the C program will be doing first is, first A will be multiplied with B, and then that result will be divided by C. But on the other case, if we put a bracket here, A star B by C. So if we put a bracket here, then obviously this one will be evaluated first, then only this will be done. So that is because the bracket is having a high precedence over the plus divided by or remainder operator. Then the plus and minus, the binary plus as well as that is the addition and the subtraction operation. Both these operators are having the same precedence, and their associativity in that case is also left to right. Then the left shift as well as right shift, they are having the same precedence. Then their associativity is left to right. Then less than or equal to, greater than or equal to, they are having high precedence. the same precedence, not high precedence, the same precedence. They are having the same precedence. So in that case also the associativity is left to right. So as the row, in a single row, whatever appears, they are having the same precedence. Then comes up the equal to and not equal to. They are having the same precedence and their associativity is left to right. Then bitwise and, bitwise exclusive or, bitwise or, logical and, logical or, and conditional operator. And these are having different precedences as the ampersand. The bitwise and is having a higher precedence than the bitwise exclusive or bitwise or. So that is the low operator with the lowest precedence is the conditional operator. And in all these cases, the associativity is left to right. That is, if multiple bitwise exclusive or are coming, so of course A exclusive or, B exclusive or, C. So first what we will be evaluating is A exclusive or B, and then only this one will be coming up. This particular value, say it is D, then D exclusive or C will be active. So that is how the operator precedence as well as associativity is related. So let's see an example in which the sum of the operator precedences, not all the one, only the arithmetic operator precedences are displayed or described. So this is a program which is written to explain the operator precedence in the case of arithmetic operators only. So we have 5 integer values. Integer A is defined as 20, integer B is initialized as 10, and C is initialized as 15, and D as 5. Then integer E is not initialized because it should be the value that is taken, that is obtained by evaluating the different expressions. So our first expression is E equal to A plus B star C by D. So in this case, since the bracket is already there, the first whatever is evaluated will be whatever is within the brackets. So it is A plus B. A is 20 and B is 10. So it is evaluated as A plus B, that is 20 plus 10, that is 30. Then it is multiplied with the C. C is 15. Then 30 is multiplied with the C, that is 30 into 15, that is 450. Then it is divided by 5. D is 5. So it is divided with 5. So 450 divided by 5, that is 90. That is what the value that is obtained for C in this case. And then the second expression here, that is A plus B into C. So again, in this case also it is the same value will be obtained because there is a bracket A plus B, and this multiplied by C is since it is within the bracket, that will be happening next. Then this is again 30 into 15 divided by 5. So that will be happening in this case also. In the third case, that is E equal to A plus B into C divided by D. So what happens is A plus B will be evaluated first, then C divided by D will be evaluated, then both will be multiplied. So that is it. 30 multiplied by 15 divided by 5. So 30 is 30 multiplied by 15 by 5 is 3. So 30 multiplied by 3. So that is again 90. So in the first 3 cases, the values will be the same. That is the expression is evaluated to 90. Then in the fourth case, E equal to A plus B multiplied by C. So C here, A plus B is not inside the bracket. Instead, B divided by B multiplied by C is within the bracket. So first, what will be evaluated is this expression. This B multiplied by C will be evaluated first. That is B into C. B is 10 and C is 15. So 10 into 15, that is 150 will be evaluated. Then divided by D. D is 5. 150 divided by 5. That is 30. So that is this expression, this whatever is towards the right of this plus symbol will be evaluated to 30, and A is 20. 20 plus 30, that will be 50. So this expression will be evaluated to 50. So let's see whether our assumptions or our calculations are right in the case of C programming also. Yeah, it is right. So the first three are evaluated to 90 and the last one is evaluated to 50. That is how the operator precedence in the case of arithmetic operators comes. So you have to use the brackets wisely in order to get the accurate answer, the real answer that is required. That will be the output of the given expression. So that is the operator precedence. And there are some other assignment operators are also there. So in the case of assignment operators, all the assignment operators are having almost the same precedence is there. Their associativity is from right to left. So that is from right to left. In this direction, their associativity comes. So that is there are different types of assignment operators are there. We have seen all the assignment operators in the previous class, and these assignment operators are having the same precedence, and mostly the more than one assignment operators doesn't comes together in a single expression, just because in some rare cases it may come up, and in that case the associativity is from right to left. So that is the rightmost assignment is first done, then the next rightmost, next rightmost, etc. Up to at the last the leftmost assignment is being done. Now the next topic in our discussion is about the type conversion. The type conversion is nothing but during the expressions. During the expression, some of the variables may be integers, some others may be say double, some others may be float, etc., etc. So in that case, how the expression will be evaluated and what will be the type of the data that is output, or that is the result of this particular expression. That is what is known as the type conversion. So when variables and constants of different types, different data types are combined in an expression, then they are converted to the same data type. So what happens in C programming is that even though the different variables or the different constants in an expression are of different data types, they are converted to the same data type in order to do the calculations. That is what is happening. So the process of converting one predefined type into another is called type conversion. So say integer is to be converted to float in some cases. So that is known as the type conversion. Or in some cases, the float is to be converted to double. So that is also type conversion. Or a character is to be converted to integer. So that is type conversion. And the type conversion in C can be classified into two following groups. The main two types, the two types of conversion are, or the types can be classified into two different types. The one is the implicit type conversion, and the second one is the explicit type conversion. In the implicit type conversion, the C programming does the conversion, and the programmer or the user have no knowledge about, or they are not bothered about the type conversion that is happening. But in the case of explicit type conversion, the programmer gives a command or a particular keyword such that the, whatever is after that particular keyword will be converted to a specific type. So let's see the different types. In the case of implicit type conversion, the type conversion is performed automatically by the compiler without the programmer's intervention. So that is in the case of implicit type conversion, the programmer has no role. He is not bothered about, or he is not aware of the type conversion that is happening. Then it is also known as the type promotion. This is known as the type promotion just because in all the cases, the type conversion, the implicit type conversion happens to the higher level. that is a higher level of precision. The compiler converts all operands into the data type of the largest operand. So whichever is the largest operand, like integer, float, and double. If we consider, say, int, float, and double. If we consider these three types of data, obviously integer has a lower size than the float, and the float has a lower size than the double. So what happens is, if an expression involves all these three types of data, all the data will be converted to the largest operand, that is the double, will be converted to double. So that is the implicit type conversion. In implicit type conversion, what happens is all the characters, say we have a character B is the character, then this one is converted to the corresponding ASCII code. This will be converted to the corresponding ASCII code. Say this is 98. So this is has an ASCII code of 98. So this will be the B. The character B will be converted to integer 98. So that is the implicit data type conversion. That is, all characters are converted to corresponding ASCII code. So if B is there, the character B is there, the corresponding ASCII code is 98. So if I put 10 plus B, if I put 10 plus B, in that case, if B is not defined as a specific variable, so what this will be resulting will be 98 plus 10, that is 108. So this is how the conversion happens. Then all the floats are converted to doubles. This is automatic conversion, that is, all the floats will be converted to doubles. If one of the element in that expression is a double, then all the floats present in that particular expression will be converted to doubles. Then for all operand pairs, if one of the operands is double, the other one is converted to double. So if one is integer and the other one is float, obviously the result will be float, and the data type of the result, will have to be float. And if either operand is long integer, then other will be converted to long integer. So if one of the operand is long integer, say long integer and float, in this case, whatever is this float, the float value, whichever value is accepted by or enveloped by this float, in that case, that particular value will be converted to long integer. So that is the condition. That is how data type conversion happens. It is converted into the higher type of the largest type within that particular expression. In an expression containing long integer and float, obviously long integer is having a higher range of values. That is why it is known as the largest among these two, or the larger among these two. Then comes the explicit type conversion. The type conversion performed by the programmer by posing the data type of the expression of specific type. That is, the programmer knowingly does something or inserts some specific code so that the data is converted. This is known as the explicit type conversion is known as the typecasting. So in this case, the higher value of a higher type can be typecast to a data of lower type. So typecasting in C is done in the following form. So that is, within bracket we put the data types, like within bracket we put integer, and here say some expression. The expression can be a constant value or any valid expression in C can be possible. So any the data type is any valid C data type. It can be integer, character, or a double, etc., etc. Any data type can be put inside this brackets. So then the next one will be some expression. It can be A only. a variable a can only be given. So that it can be the expression may be a constant or a variable or again an expression itself. So that's it. Then for example, x equal to int. So this particular statement does the type conversion or the typecasting. So int, so whatever is calculated using this particular statement will be converted to integer. So the x will be an integer value. Even if a is float say 7.5. And b into d b is say 2.5 and d is say 2. So what is happening? 7.5 plus 2.5 into 2. So that is what is coming up. In this case, since the operator precedence of multiplication is higher, 2.5 into 2 will be happening first. So it is 5. 7.5 plus 5. This expression will be evaluated to 12.5. So since this is an integer, that the decimal part will be truncated and the answer will be 12 only, because this is an integer. So x will be assigned with a value 12 if we does a typecasting using the integer in this case. On the other case, if we typecast it to double, then there will be a number of zeros to the right of this answer. This is just because it is the precision, how many digits can be possible after that decimal digit. So that is explicit type conversion. In the explicit type conversion, what we does is we put the data type within brackets in front of the expression. So during the explicit type conversion, the following rules have to be followed while converting the expression from one type to another to avoid the loss of information. All integer types to be converted to float, all float types to be converted to double, all character types to be converted to integer. All characters, as I said in the previous case, a. If we have a character a, then it is to be converted to the corresponding ASCII value, ASCII integer. So in the case of a, it is 97. So if a is converted to integer, it will be 97. The result will be 97. So let's see some of the examples, two examples regarding this type conversion. Yeah. This is an implicit type conversion where the type conversion is not done by the person who is doing the program. And in this case, an integer value I is equal to 17 is defined. Then a float value j equal to 17.0 is defined. A character c is defined as c. The character c is c itself. Then integer someone is defined and float sum2 is defined. So we find out the someone, the integer someone as I plus c. I is an integer 17, so it is an integer. C is, as I said, the ASCII value. It will take the ASCII value of C because this is character. No character can be directly added to a specific integer. So what happens is, out of these two, character as well as integer, the higher data type is the integer. So the character is converted to integer. So C is converted to integer. C is the ASCII value of C is 99. So C will be converted to here, and it will print I plus C. That is, I is 17 and C is 99. So this will be added together to get 116. And that value will be integer because there is happening no type conversion and both these values are integers. So this value will also be an integer. So value of sum percentage d n sum1. Then sum2 is calculated as j plus c. J is also initialized at 17, but here there is a 0.0 also, 17.0. So that means it is a float. So j is a float value. 17.0, and C is again a character, I mean 99. So in this case, this is a float as well as this is a character. I mean, this is a character which can be converted to integer. So obviously the integer has to be converted to float. That is, J is float, so C will also become float. That is 116. I mean 99 is the integer value of C. So the corresponding float value will be 99.0. So C will be converted to 99.0. So plus J, that is 17.0. 99 plus 17.0 will give you 116.0. So here what will be printed? The value of the sum will be 116.00. So here we will put as sum 1 and here we will put as sum 2. So now let us run the program and check whether our assumptions were right. Yeah. See, the value of sum 1 is 116 because it is an integer value. And the sum of value of sum 2 is 116.000000. So that is the case. That is the case with the float. So since J is a float, this one is also converted to float. So that is how we will get 116.000. So that is about the type conversion, the implicit type, data type conversion. Now let us see an explicit type data conversion. So in this case, integer sum is defined as 17 and sum is defined as 17 and count is defined as 5. And two double variables are declared. Double mean integer as well as mean double. So in this case, what we does is the mean integer is defined as a double, and here what we does is we are doing an integer division. See, sum is an integer and count is an integer. Sum is an integer and count is an integer. So the result of sum divided by count, that will be an integer. And since mean integer is a double value, this integer, the result of this integer will be converted into a double value, and then that double value will be printed here. In this case, in the next line, what happens is the mean double. So in this case, we does a typecasting, that is the double, this particular statement or a particular token inside this one, the double within the brackets. The term double within the brackets is the typecasting. So this will typecast the result of this one, that is sum divided by count. That is the integers. That is actually integers, but that division will be converted to the double type division, and the result is assigned to mean double. Then the mean double will be printed. So let us see how this will be happening. Compiled it, then ran it. So while executing, see the value of mean in the first statement, the value of the mean, that is mean integer. So that is 3.000. Why it is 3.000? Because here what happens is here it is the integer division that is happening. 17 divided by 5. If it is an integer division, you know that 17 divided by 5 is 3.4. But since it is an integer division, the decimal part is truncated off. So what happens is it will result in 3. So this value, this sum divided by count in this line will result in 3. And since mean integer is a double, so that is why it is coming up 0.0000. But here in this line 11, what happens is we are typecasting this sum divided by count as double. So what happens is the sum is converted to double. Sum is 17, so it becomes 17.0, and then count is divided by 5. So 17.0 divided by count 5. So that will give you 3.4. Then that 3.4 is converted to mean double. So this is the mean double. So mean double is of type double. So it will be having 3.4 and 0.0000. So that is how the typecasting is done in an explicit way. In an explicit way, when you have to do the typecasting, what you have to do is you have to put the corresponding type in front of the variable. In front of the variable that is to be typecasted. And in this case, we typecasted an integer variable to a double variable. That is what's happening in this program. That's why we get the value of mean as 3.4. And that is about the explicit type data conversion. So in this class, we discussed about the operator precedence and the data type conversion, the two different types of data type conversion. The type conversion we have discussed, the implicit type conversion as well as the explicit type conversion. In the implicit type, the C programming, the compiler does the type conversion on its own. And in the explicit type conversion, the programmer has to input certain specific commands so that the typecasting is done. And that's all for today. Thank you.